Good evening, everyone. Um, Thank you for coming. It's going to be a very exciting session, I hope, because we have three very exciting gentlemen here with me. First of all, we have Pierre from Notpla, we have Antonio from Fluix, and we have Jared from Biomimicry Institute in the US, and myself, Kasper Poulsen from the UPC in Barcelona. And I will try to chair this session and also tell a little bit about why I'm here. But first, I think I would like to give the words to the gentleman here. So maybe Pierre, you can start to talk about your company and what you're doing there, and
sure.
what wild ideas that made you found this company. Yeah.
So I'm a co-founder of Notpla. We are a packaging startup. We develop alternatives to single-use plastics. We are all using a lot of kind of like plastic that ends up being kind of like thrown away. And in a way, it's the wrong material for the job. It's indestructible, whereas if you look at nature, the peels of fruits are essentially kind of like fertilizer for the earth. So the idea that we had was if we can make packaging more like a fruit, we have something that is like by nature more circular. So we've been looking at lots of materials, but we've kind of like honed in on seaweed. So we think that seaweed is quite an incredible biomass to use for packaging. Seaweed grows extremely fast. Some of the seaweed we use grow up to 1 meter per day. So it's one of the fastest growing organisms on the planet. It doesn't use fresh water or fertilizer to grow. It sequesters carbon. And at end of life, it's naturally biodegradable. It doesn't require any human intervention. So we're essentially developing from London a range of different packaging solutions, from takeaway boxes to little kind of like energy gel sachets for races, flexible films, rigid materials, cutlery, all made from seaweed so that we can have something that if we lose track of it, it never creates a long-lasting waste. And in terms of where we are at the moment, we've kind of like finalized the industrialization of our products. So we're now kind of like active in 8 countries in Europe. In the last 18 months, we've replaced about 3 million single-use plastic units from being kind of like used by our products. We have big partnerships with delivery company like Just Eat or sports retailer like Decathlon to try to help those brands switch from like plastic to a more natural material like seaweed.
What just to ask you one question, what is the main difference between the typical bioplastic product and then your product?
Yeah, so actually it's interesting because bioplastics are still plastics. Basically, there's 2 criteria for defining what a plastic is. So if you take a polymer, you can have natural polymers, but you can have kind of like non-natural polymers, and those are like the plastic category. So if a bioplastic, you say, take PLA, one of the main bioplastics made from cornstarch, it's a plastic because you take it from like the starch level and then you polymerize it like by a man-made kind of like process, and that like chemical transformation is not happening in nature, so that's what makes it a plastic. So there's this category of native polymers, things that are existing abundantly in nature without any kind of like chemical modification, and those are the groups we work with. Polysaccharides that come from trees, from like plants, from seaweed, proteins. All of these materials are basically here for about 100 million years, and we can use them knowing that like they're never going to create a long-lasting waste at the end of life.
Yeah, so just to clarify the semantics here, so there's bio-based plastics that are made from some bio-source, and then are completely biodegradable bio-based plastics like
correct
yours, right?
Yeah. Like the worst case is like you take petroleum kind of like derivatives and then you make plastic with it.
Yeah.
That's kind of like fossil fuel, and that's kind of like an indestructible material. But like the most virtuous case is you just use the things that are already abundant in nature, and that's a bit the opportunity with these native polymers, is that basically nature has been using those building blocks for a few hundreds of millions of years.
Cool, thank you very much. Antonio, maybe you can tell about your company.
Sure. I'm one of the co-founders of Liux, which is a sustainable mobility company. And one of the things which I think is the one that relates to this panel is what we're doing is we're changing the materials with which mainly our cars are built, which are in general metals. And we're building cars with bio-based materials, in our case with a composite, which behaves similarly to carbon fiber or glass fiber. But in our case, both the fiber and the resin are bio-based. And so we're using a linen fiber and a bio-based resin. Basically trying to get back to the origins and instead of mining, and we were commenting before, doing all sorts of super complex and energy intensive processes. We're trying to keep it simple, get to very abundant, very sustainable, recyclable, light materials. And actually, we have already proven that we are competitive with metals in terms of price. We reduce weight 30% compared to similar pieces, and we reduce carbon footprint at least 50%. So that's what we're doing.
So your first product, is it already on the market, or will it come
No.
on the market, and what will it be?
So we presented the first prototype, functional prototype, our first car in November last year. Now we're developing the second one, the second car, which is the one we're going to be industrializing. And the idea is we have to be in the market in 2025.
And that is for a full car, or will you make the door of someone else's car?
Full car.
Okay.
Full car, yes.
So it's very ambitious goal, right? Are you going to?
Yeah, I mean,
are you going to make all the materials yourself, or you going?
No. We assemble part of. But I mean, the design is fully ours. The battery packs are modular. You can extract them easily. You can upgrade them. You can give them a second life. We're working a lot with 3D printing for the modes of production of the cars. And I mean, don't imagine a gigafactory. The product itself, the car is very simple. It's a 2-seater small car, very efficient, very light. And the factory we're planning is a very small factory. Don't imagine a Tesla gigafactory. It's quite a more simple thing.
Okay, and we are talking in the beginning or the end in 2025. I mean,
Beginning should be.
Okay, so we have 18 months and
I
we'll
don't know
see your
what
car on
I'm
the
doing
road.
here.
Super excited, super exciting. I don't want to stress you. Sorry. So Jared, can you tell us about what you're working with?
Yeah, happy to. So I'm the Director of Innovation at the Biomimicry Institute, and we support startups and startup founders like these guys over here. And we exist because we like to say that a sustainable world already exists in nature all around us. We just have to learn from these millions of years of evolution about how to bring that into our human-built environment. And there's a couple themes that I think we already touched on, but I'll try to summarize. And some of the things to think about in nature is that almost all of the energy, not all, but almost all of the energy that fuels natural systems comes from the sun. Even the food we eat that was initially captured by the sun. Almost all chemical reactions in nature happen in water, and almost all of those reactions happen at room temperature. But if we think about our current manufacturing processes, they're often heating things up to 1,000 degrees Celsius, or they're using all kinds of crazy acids to create new chemicals and new materials. So what we look to do is we look to support researchers and then also early stage startups that are trying to reinvent this material palette. How can we create new materials or chemistries that kind of follow some of those themes so that we don't have to worry about what happens to our materials at the end of life. It will decompose, and entropy will take that away and turn that into a new building block for new materials down the line. I'm excited to share some more stories of biomimicry with you all today.
Thank you very much. And I'll just tell a little bit about what we're working on, and this is related to energy. And maybe you don't know this, but in the end use of energy in EU, 25% is used for powering something, electric energy. 25% is used for transportation. But then we have 50%. What is that? What are we using half of our energy for? It's heating something. So half of our energy use in EU is going into heating. And most of that energy is from burning something. That's wood or coal or oil, most of it. And in my research group, we are trying to develop alternative ways to creating stored chemical energy. If you look at how the oil has been made in the beginning, it was a plant like this one that absorbed sunlight, transformed the CO2 into cellulose, and that is what we later burn, that stored chemical energy. And then when we try to use it, we burn the plant, we burn the oil, and we create emissions. In my research, we are trying to get away from burning. We don't want to burn anything. So we are creating a new material that is based on a molecule. It absorbs light. It's converted into another molecule. And when this molecule can store the chemical energy for up to 20 years, and then when we trigger the heat release, the energy release, it's converted back to the original molecule. So we can create a cycle of two materials where the only input is light and the only output is heat on demand. And by that, we can create an emission-free system, sort of inspired by nature, based on a bio-based chemical that we are developing. And that is sort of one of the projects we are working on and trying to get ready for creating a startup company maybe in the coming years. But right now, it's still in the university domain. So coming back to the panel here, maybe Pierre, you were one of the founders of your company. Now we're thinking about. Now I would like you to think about the wild ideas. I mean, what made you create this company? What was I don't know how many years ago when you started. I mean, you told me now you have 70 people. You have made 3 million packages this year, but maybe 5 or 10 years ago, there was a 5 or 10 years younger Pierre with a wild idea. What did you think back then?
Yeah. So actually, the project started in our kitchen with my co-founder. I used to be a packaging engineer working for L'Oreal, making kind of like hundreds of millions of single-use plastics. And then I realized that was not for me. I quit that job and I came to study at Imperial College in London. And the project really started with this kind of like this interest in how we could make man-made fruits, how we could kind of like leverage natural materials, limiting ourselves to kind of like cupboard food kind of like ingredients. So the very first kind of like prototypes were made in our kitchen with essentially the recipe for making fake caviar. Yeah. So this spherification, you use an extract from brown seaweed and you kind of like mix it with a salt, and all of a sudden you can create little droplets. And later, like in the 90s, Ferran Adria created a whole range of kind of like molecular gastronomy techniques. But all this technology kind of like just stayed in the food space. It was used for like fancy desserts, but not really kind of like for anything else. And an interesting thing is that the more we kind of like learn about seaweed, we realize that it was a very kind of like used material up until the kind of like petrochemical revolution. Mm-hmm. In the UK, where there is no longer any kind of like seaweed extractors, in the 1800s, about 100,000 people worked in the seaweed industry in Scotland, and the three kind of like big plants closed in the 70s. So we used to use nature a lot more for a lot of kind of like the things we use every day. And I think that that kind of like realization that after kind of like the frenzy of creating kind of like every material imaginable from like petrochemically derived kind of like materials has now kind of like come to bite us. We are just going back to a lot of things we used to know how to do. So I think that there was something exciting about creating a form factor and kind of like using materials that are inherently kind of like already in nature, because then, as you said, like it's the bulletproof. Like if I lose track of my material, I know I'm never creating a long-lasting waste. So I think that wild idea was like, if we make something that you can literally kind of like make in your kitchen and eat, probably that's never going to create any harm. And that was the kind of like the exciting part.
Oh, cool. So what was the, if you should call it, the eureka technology moment of your startup? I mean, what was it? Was it an invention? Do you have any technology that allows you to do this? And can you tell us a little bit about how you discovered that?
I think that like actually the eureka moment for us was we made those first kind of like transparent bubbles containing kind of like water or kind of like different drinks in our kitchen. And like we literally were showing it to our flatmates, and we're like, "Whoa!" And so we're like, "Okay, that's going to be the name." So it's called Oho. and at that point, we found it interesting, but it was like so far from being like resolved or anything that we kind of like closed the project, move on to the next kind of like student project. But we still made a little video that like shared that kind of like recipe with the whole internet as Creative Commons. People could just kind of like replicate this in their kitchen. And to our surprise, that video went completely viral. We had like over 100 million views on kind of like social. And we're like, wow, people are really excited about alternative materials. And it feels like probably like big companies aren't really delivering that kind of like mix of alternatives that people aspire to have. And I think that's like the Eureka moment was just like, people are really into this thing. Maybe we should kind of like double down and make it happen.
Yeah, I saw that video, and I was not sure if it was real or it was fake technology. It was so unreal. These water bubbles is like, and then you make it happen. Really cool. So, Antonio, can you maybe also if you go back in time, what is sort of the dream that made you create your company?
So my case was during COVID. We were about to close my previous project, my previous company, which is called Awara. It's a social enterprise also in the field of sustainability and social impact. We didn't close it finally, but at that time we thought that maybe we would have to close it because 90% of our sales depended on restaurants. So with everything shut down, it was impossible to. No business left. So I started thinking, okay, now what am I gonna do? I cannot work in a big corporate. I'm useless for them. So I'm gonna have to start something from scratch again. One day I was super depressed, actually, at my room during COVID, in one of these lockdowns. And I Googled what are the most polluting sectors in the planet. And I found that most of graphics talked about the same industries, which were food and beverage, clothing, fashion. And then three that were very common were industry and energy generation and transport. And so for some reason at that moment I thought, industry, building, energy generation, electric, transport, cars. And so we should try to build cars in a more sustainable way. 25% of equivalent CO2 emissions come from transport. 70% of that 25% comes from road transport. So I thought maybe building a super sustainable car would be something cool. And so I started talking to people about this idea. Everyone told me it was a stupid thing, impossible, ridiculous, impossible to compete, super complicated industry, etc. But then a friend of mine told me about some crazy guy from Alicante that had built a car and presented it in Le Mans in 2017. He had built in a garage there 1,000 horsepower hybrid supercar, crazy, like something quite mythical. I got his number. I went to Alicante and I met my partner. And he was the first guy that I met that when I told him, okay, I want to build the most sustainable car on the planet, he said, okay, let's do it. He liked the idea, so we started a conversation. He had the whole experience on the design and development of transport in general, boats, trains, cars. And I came with this sustainability vision, product. And so we joined forces and we started working. And 2 years after, we're here. So it's kind of not very planned. Things come and we just surf the wave.
Cool. So I've been living 12 years in Gothenburg in Sweden. It's the home of Volvo Trucks, the biggest truck company in the world. And if I talk to them, they have a turnover of about 8 billion euro or more. And I talk to them about new materials. They say, we only want something that has been tested for like 20 years. And now you are here 2 years later, and you are putting in new materials in your super futuristic wild car. How do you choose your new materials? What are you looking for, and how did you make that selection with less than 1% of the budget of Volvo Trucks?
So I guess having less than 1% of that budget makes you think differently. So the briefing we gave ourselves was very specific. We need something that is abundant, something that doesn't depend on a complicated mining sector, something that can be light, because electric cars need light materials for efficiency, something that can be fully recycled, and if possible, something that comes from nature, something that comes from organic sources. And then the last requirement was something that you can produce at scale, which is the big thing. It's easy. It's not easy. But you can make a prototype, but you need to scale it, which is a big challenge here. And so we've been working with several different materials, analyzing what others are doing. And as we don't have many shots, we had to be very certain with the first one. And we've been testing it with the University of Valencia and ITEC's specialized laboratories, and the results are quite amazing.
Cool. Very exciting. I think we are almost running out of time, so I think we will have to go to Jared here. And maybe if I can ask you now, this is a session that's about alternative materials. Can you give some example of wild materials coming out of the work that you're doing?
Absolutely. And I'll try to connect it to these guys over here. So most of the solutions we support are coming out of years of university research. So I think that's a really interesting thing. Often we think of startup founders, we think of engineering or digital technology. Most of our founders and research are actually coming from biology and biologists, which is really interesting. So one of the ones that I'm thinking of is these biologists were studying mantis shrimp. So mantis shrimp, they look like kind of like peacocks underwater. They're these beautiful shrimp. And their punch goes faster than a bullet. So they can punch extremely fast, and they punch these really hard shells over and over again, and their club doesn't break. So scientists were wondering, well, any other material would break. Why doesn't this club break? So when they started to look at the internal architecture of that at the micro and nano level, they realized that it's structured in such a way that it dissipates stress and it dissipates the energy in the most effective way possible. Like we think that evolution has gotten that club to be as efficient as it can be. And that pattern is actually seen in other plants and animals around the world as well. So there was an amazing discovery, and now that's being applied in the composite carbon fiber sector. So now a big problem with composites and composite product is how big do you need to make this? Can you lightweight these things? So this company has found a way to lightweight some really incredible carbon fiber solutions. Some in automotive. One that I'm really excited about is that they have the potential to lightweight wind turbine blades. And the length of a blade is the limiting factor for how much energy can be made. So if you can make that lighter, you can make it longer. There's just some really incredible technologies, and it all started through this deep understanding of biology, and I think that's a wild idea.
Yeah, cool. Sure. And you've been working with, I don't know if it's tens or hundreds of companies working in materials and biomimicry. What is if there's someone out there working with technology or science or entrepreneurs wanting to bring new materials to market, what is your advice to them? What if you should sort of tell it in 1 minute?
Yeah, that is such a good question. I'd love to hear what you guys
What's
think.
your top advice?
Yeah, I think my top advice is to look to seemingly unconventional places for new material or chemistry innovations. Like, love what you were saying. You were in a lab, but also kind of going back in time. We see a lot of our companies, our successful companies, come from what would be really considered unconventional spots. They were marine biologists, or they were chemists. They were studying how ants work and how ants communicate, and finding new algorithms that could be made based on pheromones and scent rather than based on electronics and electricity. So I think there's a lot of really interesting aspects if you just kind of take a step back and look at things from a unique perspective, because that's really where I think technology breakthroughs come from.
Maybe one way of thinking about it is to ask questions that other people have not asked before. I mean, you decided to. I mean, other people have made cars before, even very fast cars or even very cheap cars, but maybe not a biodegradable or bio-based car, right? And the same with the form factor and maybe the materials were sort of known, but the form factor and the concept was a new application or new way of doing that. I think maybe that's a common denominator
Yeah.
with what is being done here, is that it's not so much about what you do, but also the questions you ask and about this.
Absolutely.
Yeah.
Yeah, absolutely.
Yeah, I would say also that there's a lot of bias. We were talking about this before. When you talk about bio-based materials and these kind of things, it's something like you're going back to the basics, because you're going back to nature and things you touch and are quite evident. And so people tend to think that this is too simple. If it's so simple, somebody would have done it before. You know. So I think we need to get rid of these biases, because, as you say, the process was invented long ago. It was used for a specific industry, and you just took it to yours, and you're doing a revolution here. So sometimes it's just very, very handy. It's not something ultra crazy sophisticated. It's like believe in what you're doing, because most people just have their own structure and they just don't want to believe things can be done differently.
Totally agree, and I think that this idea that the world is always changing, so like the situation has evolved, and the reason why no one is doing it is because no one has been the first one to apply this insight. But there's plenty of stuff that beg to be done, and it's just a matter of kind of like going for it.
Absolutely.
When we go into sort of scale up for your new technology, what are the challenges you are facing? Just the last question. How hard are we? Should we stop?
We have to close the stage. I'm
Okay.
so sorry.
Okay. Then I would like to thank all the three gentlemen, and also for you for your attention. Thank you very much for coming. Thank you.
Thank you.